Alright, guys. I would assume that it's morning to everyone. Good morning. I'm hoping that everyone is good. Okay, today we'll be doing organic chemistry, grade 12s. Yeah, we'll be doing organic chemistry, purely based on grade 12 stuff, being term 1. Alright. Okay, without wasting any time, let's utilize what is on this document. Okay. Here I've said organic chemistry carries around 30 marks of the paper. Remember, you have around 4 to 5 questions out of 10 in your multiple choice on question 1. And in question 2, as purely just organic chemistry. Question 3, still organic chemistry. Questions 4 is still organic chemistry, so it's around 40% of the paper of paper 2 that is just organic chemistry. So hence you have to make sure that you master this part, and it's a little bit easier if you focus on the exact technique, but I'll illustrate those. All right, let's start with the very first part, which is I'll have a separate recording maybe, or I'll go on the definitions where I'll be dealing with what is alkane, etc., and so forth and so forth in terms of the definition. Okay, um let's focus on alkane. In simplicity, you must have on that compound hydrogen and carbon only. There must be only those two element. It's hydrogen and carbon only. Then you talk of alkane, and there's a single bond in between those element. It's only single bond that is involved. That's what pretty much alkane is. Okay. Example of alkane that you have, and the name of alkane has to end with the last three letters here, which is A and E. Okay, you have methane, you have ethane, you have propane, you have butane, and so forth and so forth. Right. Let me make an example of an alkane as a diagram. Right. The first compound is methane, which is 1 carbon. So you have all H's around C, and it's one bond. It's just one bond. Hence, it's called alkane. If it's two C's, it's gonna be something like this. Gonna be something like this, and this would be ethane. It's gonna be like this, and it's single bond in between the element. So that's exactly what is the structure of methane. You can do as many as possible. All right, let's go back. All right, let's go to alkene. Alkene is just a derivation of this one. It's still the same as alkane, with the exception of the bond. The bond, you are now having a double bond between carbons. Okay, you must have a double bond between carbons. Okay, so that's the only difference between alkane and alkene. Is the fact that you now have a double bond. That's the only difference. Otherwise, everything else is remain the same. But the naming now is gonna change a little bit. It's gonna take a suffix of this one, meaning the last three letters. Hence, you are having a thing instead of a thing instead of a thing. All right. Let me also illustrate that on the Okay, you start. It has to start from two carbons here. Okay, so you have a double bond, and as you have H here, you might have H here, and this is already enough because there must be 4 bonds in each C carbon. I mean, in each C. Okay, so even here, so it's already enough. So that is your 18. That is your 18. Um, what about, okay, number of hydrogen? Okay, I will also explain if how do you determine this. Okay. Um, Coming here to alkene. Alkene, you have a triple bond. That's the difference between alkene, and alkane. So here you have a triple bond. Okay. Let me illustrate that as well. For alkyne, you have two C's here, then you have triple bond in between the C's. So you only left with one bond here. It's gonna be H. You also left with one bond here. It's gonna be H as well. You can't have any extra bond here because it's gonna be four. It's gonna be 5 bonds, of which you are limited to only four bonds in each carbon or in each C. Okay, if it's propane or something that have more than 2 carbon, you can have something like this, and maybe your triple bond can be here. Then you just join, and these two, they are already enough because you already have 4 bonds here. Here you still left with 3 bonds. You have your H, have your H, and have your H, and this is enough. Have your H, have your H, have your H, and this is enough. Then that is your structure. Okay, that's it. Alright, that's it for alkene. Number of, okay, let's try to determine how many number of oxygen, hydrogen, do you have to have in each compound. Okay, for alkene, the number of oxygen in the methane, if you have 1 carbon, you have 4 hydrogen. If you have 2 carbon, you have 6 hydrogen. So do you see the difference now? It means that you can, if you say, okay, in terms of formula, if you say here it's N, it's a small letter here, it's N. Let me show on the board. So that would mean if we were to formulate this, you have C N H, it's gonna be N, it's 2N, yeah, it's 2N, yeah, it's just 2N, it has to be just 2N. Okay, that's what it is. Okay, that would mean if we want methane, in methane, how many carbon do you have? It's 1, so it's gonna be 1. Okay, okay, how many carbon do you have? It's still 1. That would mean it's gonna be 1 here plus, it has to be plus 2 here, plus 2. So that would mean that your compound ended up being something like this. Okay, what if you want ethane? Okay. For ethane, it's gonna be 2 here because you have 2 hydrogen, carbon. And in your formula you have 2 here. It's gonna be 2. This 2 is gonna be 2 plus the 2 of the formula. So you ended up having 2. This time this is 4 plus 2 is 6, so you have 6. Okay, even if you were to throw a structure here, you get that structure. So how many number of hydrogen you have? Let me see how many number of hydrogen do I have here. Okay, this 1 2 3 4 5 6, which is the 6. Okay, here is the same thing. Okay, so it's gonna be 4, the same thing. Okay, but here you don't have this plus 2. You don't have this plus 2 here. Okay, you just have CnH2n. Okay, I don't have that plus 2. Okay, let's try to come up with a compound. Let's say we have ethane because it starts with ethane. Okay, for ethane is 2C. It's 2C. H, there's 2 here. 2. N, what is N? Is 2. Then it's 2. So we end up having something like this. Okay, let's try to draw a compound to see if this is correct. It's gonna be CC. We have to have a double bond here. Okay, we need 1 here. Okay, and this is enough. This is enough because we have 4 bonds, and even here we need 1, and we need this one, and this is enough. So 1 2 3 4, and this is 4. You can do the rest. All right, here what you do, you see if there's a decline of this 2. You see there's a decline of this 2 because we had 2 here. You don't have 2, meaning we have to minus 2 here to get here. Okay, even from here we have to subtract 2 to get here. Let's try to see how that work. We have CnH2n minus 2 because that's how we do it. From moving here to here, we have to subtract 2 so that we get here. From here to here, we subtract 2 again to get here. Okay, let's try to see a compound. Ethyne. Let's say ethyne is 2 Cs, H here, 2, which is the formula, N, which is 2 here, minus 2. That's what we're saying. So the end result will be 2. It's going to be 4 minus 2, which is 2. Okay, let's try to draw a compound for that and see if it does work or not. It's CC because there are 2. 3 bonds, triple bonds, 1H, 1H, and it's enough because there are 4 bonds in this C and there are 4 bonds in this C. It's enough, and that is 2. 1 2, and that is 2. Even if we can test propane is 3 is 2 by 2, N is 3 minus 2, right? So we end up having 3H, 3C. How many H should we have? This is going to be 6. 2 times 3 is 6, minus this is going to be 4. Okay, so let's test this on the sketch. We have 3 C's. So we can have a triple bond here. We need only 1 bond here. We need only 1 bond. Okay, we need 3 here. We need 3 bond more. Okay, we can have it moving upwards like this, and another bond. Let's take this off. Okay, let's count 1, 2, 3, 4, and here we have 4. Do you see how many C's? Is 3. 1, 2, 3. Okay, that's how we work this out. Okay, let's go back to our explanation. Going to ketone. For ketone, we have a functional group of this, meaning there must be a bond between C and O being oxygen. That bond should be a double bond between oxygen and carbon. And for it to be a ketone, the double bond between oxygen and carbon should be always in the middle, not at the end or at the beginning. It should be in the middle. If it's at the end or at the beginning, then it's gonna be aldehyde. It's no longer a ketone, it's gonna be aldehyde. Let me show that to you now, just now. Okay, that means for ketones, there must be a double bond between C and O. Okay, there must be that double bond. But all we are saying is that the double bond should be in the carbon that is in between or is in the middle. Meaning if we have 3 C's, the double bond should be here. And you can do everything, but the double bond should be here. Then it will be a ketone. If the double bond is here, then it's an aldehyde. It's no longer a ketone. If it's here, it's no longer a ketone. It's an aldehyde, not a ketone. That's the only difference. If it's in the middle, then that is a ketone. Okay. I think we are fine with this. Let's go further. And the naming thereof should contain that 1 because it's a ketone. I don't know where this. It's a ketone. Okay. So your end name should contain, or your suffix or your 3 letters should contain. If it's a propane, it's gonna be propanol. It has to have that 1 on the end, right? For carboxylic acid, carboxylic acid, it's still this one. It's still the same as this one, but the only difference is the fact that the carbon with the double bond, that is double bonded to oxygen, is also have a bond with an alcohol group. Let me illustrate that because it's gonna be complex to say in words. For carboxylic acid, okay. If you have 3 C's like this, for it to be carboxylic acid, it means that there must be a double bond between carbon and oxygen, and also over and above that, the same C that is double bonded with oxygen should have a bond with alcohol group. This is an alcohol with an alcohol group. Then everything else will be your hydrogen. Everything else will be your hydrogen. Okay, so this is a carboxylic acid in this case. Okay, make sure that C is always bonded with 4 bonds. Okay, that's it for carboxylic acid. Okay, let me just take alcohol, because alcohol is a bit easier. For alcohol, it's the same as alkane, but the only difference, one of hydrogen is replaced with by this group. Anything else has to be oxygen. I mean hydrogen. Anything else has to be hydrogen. But an extra bond, end of the bond should be at least be alcohol, meaning it should bond with a single bond between carbon, oxygen, and hydrogen. Okay.